Hello everyone, you're watching my YouTube channel Chemistry by Saad. I am chemistry coach, science coach. Today going to discuss a past paper, harder, challenging question that is from Edexcel A-level chemistry paper 3. I will also upload the link of this paper. Come to the question. The total amount of acid is 150 cubic centimeter. Sample A, its mole is 18 to 10 raised to the power minus 3. The mean titre in experiment 2 is 9.50 cubic centimeter. Calculate the mass of citric acid in the 150 cubic centimeter of sample. This is the question which I am going to solve. But guys, as you can see here, the question is linked with a previous part. First, we need to go over the previous part. I'm sure you must have this question paper in front of you. So guys, basically the question is this, 9. Question number 9, the pineapple juice was so yummy. It contained the weak acid, citric acid, and ascorbic acid. Student, someone conducted experiment number 1 to determine the total amount of acid. Then he conducted another experiment, which is experiment number 2, to determine the amount of ascorbic acid in the pineapple juice. So in this experiment, what they did basically, step 1, you can go over yourself as well. Step 1, 5 cubic centimeter of pineapple juice is added to conical flask, and then step 2, then step 3, and step 4. The resultant mixture is titrated with a solution of potassium iodate having this concentration. So potassium iodate, I can write as iodate ion. So iodate ion concentration is this. I am noting this because we need this. And we also need to follow these both equation. These are very important equation to solve that question. Here we need to follow the ratio, like the ratio of iodine with iodate ion. Guys, the concept, the harder concept of this question is basically I need to find the moles or amount of this acid. For this, I need iodine moles. And how I can get iodine moles? I need to compare this iodine with this iodate ion. So if somehow I can find out the moles of this iodate ion, then by comparison, I will be getting the moles of iodine. So once I have the moles of iodine, then by comparison of molar ratio, I can find the moles of this acid. And then the story would be simple. Let me explain again. Let me explain again what I am talking about. I need to find out the amount of acid. Here you can see the acid is in comparison with molar ratio of iodine. So it means I need the moles of iodine first. So how I can find the moles of iodine, guys? Can you see here? There is a comparison of iodine with iodate ion, and iodate ion concentration is given somewhere, its volume is given. So I can find the moles of iodate ion. So once I have the moles of iodate ions, then by the comparison of molar ratio, I can find the moles of this iodine. And when I find the moles of iodine, when I have the moles of iodine, then by comparison, I can find the moles of acid, and the story would be simple. Let me do. So first, I need to use this concentration. Why? Why the concentration of iodate ion? Because I need moles of iodate ion. Come back to this question. Here, the mean titer in the experiment. So this is the mean titer. So I'm gonna use the mean titer here. So 9.50, first I divide this by 1000 so that I can convert this into cubic decimeter. So 9.50 divided by 1000. This would be equals to 9.5 into 10 raised to power minus 3 cubic decimeter, and the concentration of iodate ion is 0.00100. The volume here is 9.5 into 10 raised to power minus 3. So can I find moles? Yes, I can. So moles is equals to moles of iodate is equals to concentration times volume. Concentration is 0.00100. The volume is 9.5 into 10 raised to power minus 3. So in this way, I will be getting the moles. If I am not wrong, this would be equals to 9.50 into 10 raised to power minus 6. Good. Now I have the moles of iodine. I need to note down. Please take a notebook. Note down the moles of this iodine here. Okay, guys, now this is 9.50 into 10 raised to power minus 6. Now, if I can show you the equation, yes, I can show you the equation here. You will see if you have the moles of iodate ion. So, can you find the moles of iodine? Just comes here. Compare this with this. So, IO3 iodate ion comparison with iodine. It's according to balance ratio, this is 1:3. If this is 9.50 into 10 raised to power minus 6, guys, then this is 3 times 9.50 into 10 raised to power minus 6, 3 times of this. So use calculator 2.85 into 10 raised to power minus 5 moles. Oh, guys, the moles of iodine is 2.85 into 10 raised to power minus 5. So now we need to use this equation hidden somewhere here. Yes, this. So let's compare these two. So iodine comparison with this acid. I'm just forgetting the name of acid. This is 1:1. But now the moles of iodine is 2.85 into 10 raised to power minus 5. So guys, it means the mole of this acid is 2.85 into 10 raised to power minus 5, right? So this is the mole of ascorbic acid in 5 cubic centimeter sample. Again, listen. This is the moles of ascorbic acid in 5 cubic centimeter. Again, listen. This is the moles of acid in 5 cubic centimeter. Moles of ascorbic acid in 5 cubic centimeter. Need to erase so that I can have space. Right now, what I have moles of ascorbic acid, moles of ascorbic acid, which is 2.85 into 10 raised to power minus 5. And this is in 5 cubic centimeter. So guys, if I have 150 cubic centimeter ascorbic acid, let's say I have to find moles of ascorbic acid in 150, then it means you need to multiply 2.85 with 30. Why? Because when you multiply 5 with 30, you will be getting 150. So you need to multiply the moles this with 30, then you will be getting the moles of ascorbic acid in 150 cubic centimeter. So this is the moles of ascorbic acid in 150 cubic centimeter of sample. Now total volume of acid, total volume of acid, total moles of acid, sorry, total moles of acid, totals mole of acid. Acid means ascorbic acid and citric acid. Acid means ascorbic acid and citric acid. So I have to find now moles of citric acid. So if I subtract the moles of ascorbic acid from total mole of acid, total moles of acid is this, the moles of ascorbic acid is this. So when I subtract the moles of ascorbic acid from the total mole of acid, I will be getting the moles of citric acid. That is 7.145 into 10 raised to power minus 3. Oh, yes, now I have the moles of citric acid. I need to find the mass of citric acid. So once you have moles, then by using MR, you can find. So the mass of citric acid Just multiply the moles of citric acid with the MR. MR of citric acid is 192. So you will be getting 1.37 gram. Guys, this is the answer. This is harder, challenging question. If you understand this question, do share your comment and feedback. If you do not understand, no problem. You can enjoy my tutoring one-on-one sessions. Feel free to contact. Thank you so much for watching. I must request do share this video with your class fellow. Enjoy your day.